Okay, welcome to the webinar. Good evening, good afternoon, good morning, wherever you are. So today the webinar is about build and ship your own MCP server and client. Maybe can you just show a hand? Anybody have done any MCP server, MCP client before? Just maybe thumbs up. Okay, interesting. Okay, so welcome to the webinar. Let me introduce myself. My name is Kwan Hong. You can call me KH. I'm currently working as a data engineering section lead in Roche. I'm a Google developer expert, GD in AI and machine learning. I'm also an AWS community builder in machine learning. I'm very passionate about running communities. I founded and still managing 2 communities in Malaysia, Artificial Intelligence and Machine Learning Malaysia, and the Malaysia R user group. Please do connect me in LinkedIn. I'm quite active in LinkedIn. If you have LinkedIn, please do connect me. In LinkedIn also, you will get the latest updates if there's any webinar upcoming webinars. Yeah, and then recently I also have a YouTube channel where all the webinar will be recorded and will be uploaded to here. So yes, you can see previously I have a webinar about agentic coding with Gemini CLI, and then I have done a webinar on A2A, agent-to-agent protocol. And last month I've done a webinar on how to build your AI agent using Agent Development Kit ADK. So if you are interested, please do subscribe to my channel. And also today's recording will be uploaded to this channel also. Okay, so this is the agenda for today. So again, this is a webinar. This is not a training. So it's not feasible to do a training for 1.5 hours about a topic about MCP. So the objective of today is to give you an overview, a slightly in-depth overview about what is MCP, Model Context Protocol, and then I will show you a demo, and hopefully with that it will actually allow you to get started and go and build your own MCP server and also maybe your own MCP application. Okay. So the agenda for today will be talking about what is MCP, Model Context Protocol, what is the architecture for MCP. So you have MCP host, the client, and the server. And then we talk about how does the MCP work, the elements, the transport, and the communication MCP. Of course, if you were to develop your own MCP application, you will have some SDK that you can use. So one of the SDK that we are going to focus today is using this FastMCP SDK. Then we talk about what is the use cases of MCP, personal and commercial. And then lastly is how do we deploy the MCP. If you have developed an MCP server, how do we deploy the MCP? So we can deploy our MCP using local machine in a local machine, or we can deploy over the remote server using streamable HTTP. Then of course I will end with the demo and we can conclude the session. So before I start, I will just show you what MCP can do. So if you would, if you have let's say use something like Claude Desktop. So you can see in my Claude Desktop here, so I can actually see that I have many applications connected. So I have connected to Google Drive, I got connected to my Notion, Zapier. But then at the bottom here, there's another application that is called Space Note. So this Space Note is the MCP that I developed myself. Okay, so it looks something like this. Let me show you the code. So you can see this is the code for the Space Note. Okay, it has tools, it has application that I can actually connect to my Claude Desktop. So when I run my Claude Desktop, okay, it's actually connecting to this tool that I developed myself inside in the local machine. So this is what you can do with the MCP that you develop. and then you can ask application a large language model, whether it's a Claude or ChatGPT or Gemini. You can actually connect to your MCP server in a local machine or through a remote server. Okay. Okay, so what is Model Context Protocol MCP? Okay, so Model Context Protocol was actually introduced slightly less than a year ago, November 25th, 2024. So it's actually introduced by this company Anthropic. Okay, so you can see it's about exactly like November 25th last year, they actually introduced Model Context Protocol. So in the development of large language model, 1 year seems like a very, very long time, and so many things has happened for the past 1 year, and the proliferation of all the MCP applications. You can see there are many now MCP application or server out there that people have developed within less than a year. Okay, so what is Model Context Protocol? So Model Context Protocol basically is the standard that allows the AI model, okay, to actually connect with external tools in a very consistent and structured way. Okay, so that means a Model Context Protocol MCP, it allows the AI model to have extra features where they can connect to external tools. Okay, so if you use ChatGPT or Gemini or Claude Code, if you ask it to generate a text, whatever, that is actually a pre-trained text that is next word prediction that he has done. But if you want it to have extra capability where you can actually connect to external tools, so MCP is a standard that allows the AI model to connect to external tools. So with the MCP, it basically is a universal bridge that connects AI to outside system. Okay, so it's a standard now. With the large language model now, you can connect to with MCP, via MCP, tools, data, and the memory in a very structured manner. So before MCP, so in a large language model, if let's say I want to connect to Slack or Google Drive or GitHub, I will have to connect individually a unique API. Okay, and then if there is more and more application, for every single large language model, I will have to connect one by one. So you have this what we call N by N problem. Now with MCP, I have a large language model. I will have a unified API with the Model Context Protocol. It allows me to connect the application. So I do not need to, I will solve the problem of N by M problem. So basically, you could have like chat interface like Claude Desktop or LibreChat, or you could have an IDE like your Claude Code or your VS Code or your Cursor or your Windsurf, okay? Or you have other AI application that can actually connect via MCP, okay? And this MCP allow it to connect to other application like data or file system, maybe your Postgres SQL, or maybe your Google Drive, or connect to your development tools like your GitHub, your GitLab or whatever, or maybe to your productivity tools like your Slack or Google Map. So you have one single MCP that allows all these LLM able to connect to all these tools out there. Okay, so there is a very detailed documentation available that you can actually go and read about it. It's actually via this Model Context Protocol website. So you can see here, they talk about the architecture, the server, the client, then how do you develop your own server, connect to your remote server, and many more. So this is a very detailed documentation that you can, if you want to refer to, you can actually refer to it. Of course, for any open source application or protocol, it's important to have a complete documentation for developer to develop application from it. Okay, so the Model Context Protocol basically, okay, is actually a standardized large language model application to allow it to connect to your tools and your data source. Okay, so there's many ways that you can actually connect to your external tools. Before MCP, people will use all these REST API. So with REST API, basically is standardized how web applications interact with backend. Then you have some language specific protocol. Okay, certain language will have its own specific protocol that it allows the IDE to interact with the language specific tools. Okay, but now as we progress with MCP, comes MCP now, you have a very standardized way that allows the AI application to interact with external system. Okay, so with MCP now, the MCP server can be reused by various applications. So you only need to develop one MCP server. For example, I can just develop one MCP server for Google Drive, and this one MCP server can be used by many different types of AI application. Okay, it could be MCP compatible AI assistant, maybe like your Gemini or your Claude, or maybe your ChatGPT. Okay, if there is compatible, then you can actually access to this Google Drive MCP server. It could be an AI agent. Okay, you can develop an AI agent, and then the AI agent is already built in with this MCP client. You can also get access to your MCP server. Okay, or it could be any MCP compatible desktop application or IDE. It could be your VS Code, it could be your Cursor, it could be your Windsurf, okay, or PyCharm. Okay, as long as it's compatible, you can access to this MCP server. So you can see the benefits here. You do not need to consider what application is accessing your this MCP server. This MCP server can be connected to different type applications. You just have to develop one MCP server with the standard protocol by MCP. It can allow you to access to the tools, which is the Google Drive. So why does MCP matter? So depend on where you sit the ecosystem. Okay, it actually have a range of benefit. Let's say you are a developer. Okay, so what's the benefit for you as a developer? So for developer, the MCP will reduce your development time and the complexity for you to integrate your application, your AI application or your agent. Okay, so last time, if you build an application, if you need to connect to a certain tools, you need to figure out the API. You need to do the authentication. Then, if you connect another tools again, you have to do that connection, the authentication and the connection again. Now with MCP, okay, it actually allows you to reduce the development time. Okay, if you are AI application agent, okay, so MCP will allow the ecosystem now with the application or the AI agent can have access to all the data source, the tools, and this definitely will enhance capability and the user experience. So last time, if you talk about just use ChatGPT, okay, if you ask certain question, maybe recent events or recent news, or you want to access a file, then the large language model will not able to do that. Now with MCP, you're able to connect to any tools that you want, and then it definitely improve the capability and the user experience. And then you as an end user, okay, now MCP allow you to have able to access data and take action on your behalf when necessary. Like I showed you just now, I can actually develop my own MCP server, run on my own local machine and connect to my Claude Desktop. Okay, so I can do that. So with end user now, definitely it allow you to have more capability and then allow you to access your data and maybe take action. The large language model or the AI agent can do things on your behalf. Okay, so so before we start jumping into building our MCP application, we need to understand the architecture of MCP. Okay, so the MCP follow this client-server architecture. Okay, that means there is a client that communicate with the server, and this client must be stored or available or something what we call MCP host. Okay, so a host can be application like Claude Desktop or Claude Code or Windsurf or this Cursor. Okay, or VS Code. That is a host. Inside the host, you must have something what we call a client. Okay, so MCP host, okay, is like a program. Can be a Claude Desktop, can be IDE, can be a tools that allow you to access data to the MCP. Okay, so normally in the current situation, most of the hosts now already built in with MCP client. Okay, so most of the time you do not need to build in the client MCP client. Okay, so the MCP client will sit inside the MCP host, and the MCP client will have a one-to-one connection with the server. Okay, next is the MCP server. So this MCP server basically is a lightweight program that will allow you to expose certain capability through the Model Context Protocol. That means the server will actually allow the client to access certain capability. For example, can access certain tools, or can access certain resources, or maybe can access certain prompt. Okay, this is the three features available inside the MCP server. Okay, then you have a local data source, okay, where the MCP server can access. Okay, so you can access to maybe your Postgres SQL, your SQL server, or database or services. And then you have services, remote services that the MCP server can provide to. Okay, so it looks something like this. A user, okay, will use something what we call MCP host. Okay, so MCP host could be a cursor, could be a Claude Desktop, could be a Windsurf. Inside the MCP host, there is what we call MCP client. Okay, the MCP client. Okay, so MCP client will use the large language model available. It could be DeepSeek here, it could be ChatGPT. Okay, so your MCP client will access to the large language model, whichever that you select to. Then the client will connect to the MCP server through the MCP protocol. Okay, so the MCP server allow the MCP client to access tools like the Slack here, or the Google Drive, or the GitHub. Okay, so to develop this MCP application, you need to think about where is my MCP host, what is the large language model that I'm going to use, okay, to understand the query from the user. Okay, and then this large language model also will actually understand that what are the tools available from the MCP server, and what are the actions need to be taken by the MCP server to actually connect to the tools. Okay, so this is the important concept. You must have an MCP host. Inside the host, there is an MCP client. The MCP client will connect to the MCP server through the MCP protocol. Okay, so as we mentioned just now, the architecture of MCP is based on client and server. Okay, it's based on client and server. So a client must able to communicate with the server, and then the server must able to also communicate back to the client. So there is something what we call communication protocol. Okay, so the client and the server, how do they communicate with each other? They do what we call exchange messages. Okay, exchange messages. So there will be something what we call request. Request means the client will send something to the server. That's called a request. Okay, and then the server will respond a result to the client. That's called response. Okay, sometimes there's also notification that the server will send back. Okay, maybe there's a failure, or the tool doesn't work, whatever. That will also send back through something we call notification. And all this is actually based on this JSON RPC 2.0 format. Okay, so I know it sounds like okay, or it sounds like it is very complicated, but actually, okay, the SDK will take care of the format and messaging for you. So you do not need to specifically write all this notification response. It all will be taken care by the SDK. So basically, it looks something like this. You have the MCP host. Inside the host could be many clients, and then the client will connect to the MCP server. And then there is something what we call a transport layer. The transport layer will manage how do they transport the messages. Okay, so the messages can be transported using something what we call as standard I/O. Okay, standard I/O usually for a remote local machine, or something what we call server-side event (SSE). Okay, server-side event (SSE) basically is through a remote server. That means you can connect to a remote server, which is not in the local machine. Okay, so what's the difference between these two standard transport protocol? So you have the standard I/O. This standard I/O basically is a standard input/output. Okay, so this standard I/O is only used when you use your server, your MCP server, in a local machine. Okay, so like just now I show you, my Claude Desktop is connecting to my server, which is a code that I run in my local machine. Okay, so that is using a transport called standard I/O. Okay, so the client can start the communication with the server and communicate and terminate. Okay, so the transport will be standard I/O. Okay, if you have a remote server, that means your server is across the network. Okay, then you use the transport which is called streamable HTTP or server-side event. Okay, so why is that these two transport protocol? Okay, server-side event is a protocol that had been used at the beginning when they created this remote server, but now they are the more preferred transport for remote server is this streamable HTTP. The difference is server-side event, it must be the difference is HTTP do not need to have a state. Okay, if you're not if you don't know what is the state, doesn't matter. But just to remember, server-side event is something that must be all the event must be is a stateful event. But for streamable HTTP, not all the message event need to be in a stateful event. Just remember now, most of the time, if you have a remote server, we'll be using this streamable HTTP. Okay, so if a streaming support, okay, and then you will get a server notification. So basically, it looks something like this. Say you have like Claude or Cursor or IDE or any custom application. This will be your host. Inside your host, there will be MCP client. Okay, depending on whether you are using remote server or a local machine. If it's local machine, then you use standard I/O. If you are using remote machine, you use SSE or streamable HTTP. So local machine will use standard I/O. If it's a cloud server, you use this HTTP or SSE. Okay. Then from there, the MCP server will able to access different data sources. You have a local file or API or cloud. Okay. And all this is how you build and host your MCP server that you need to be aware of. Okay, so how does it work? So we have an MCP client. The MCP client can invoke a tools. Okay, there are many tools that the server will have. Then the MCP client can say, oh, I want to use these tools. Okay, then you also can have access to what we call resources. So resources will actually provide some context to the MCP. Then you have a prompt. Okay, so sometimes there are many prompts that the standard prompt that the server can be auto-generated or predefined prompt. Okay, like a prompt template. Okay, so for example, if I just give a command, then the MCP server know that this command will actually invoke the prompt template. Then the user do not need to type the very long prompt. You just use the prompt template. Okay, so look at here. What's the difference between tools, resources, and prompt template? Okay, so this is very important. That means whenever you talk about MCP, the only three things you need to consider is the tools, the resource, and the prompt. Okay, so what is the tools? Okay, tools is a function or tools or something that can be invoked by the client. Okay. That means, let's say MCP client, I want to do a search. That could be one tool. Or I want to send a message. Or I want to update a database record. That could be a tool. Okay. Then resources. What are resources? Resources is something similar to tools, but the resources is only for you to read only data or exposed by the server. Okay. So, for example, I want to know something, I want to provide some context to my large language model. Okay, so the context is I need to read a file. Okay, so if I read the file, after I read the file, then my large language model will have a context of what is going on. That is what we call resources. So you can access a file, you can access a database, or you can get a response from the API. Okay. Later in the demo, I'll show you in the code how does it look like, the difference between tools, resource, and the prompt. Okay, so prompt template is basically a predefined prompt or template or prompt that you already store inside your MCP server. So this is a predefined template for the AI interaction. For example, you could have a template prompt to say, or whenever a user asks for this, do a document Q&A. Or when a user asks for something, then you just do a summary. Or when a user asks for something, just output the result as JSON. So the user do not need to actually write a very long prompt, okay, to actually ask the MCP server to actually do certain action. So this, you can just use the prompt template. Okay, so I just want to show you all this communication is actually happening at the back whenever the MCP client and the MCP server interact with each other. So basically, just like if you have studied networking before, whenever two machines need to communicate, they need to start the process, initiate the process, then do this exchange of messages. Then once the messages have complete, they will terminate the process. So this is how all these messages will be communicating with the client and server through the remote local machine, through this standard I/O, standard input-output protocol. Okay, so if you have a local machine, the client and the server in the local machine, then they will use the standard input-output protocol. Okay, then if you have a server, this SSE, basically you have now a client and the server is at the remote machine. Then there will be something like this. They will start a connection, they will exchange messages, they will use the HTTP post, and then the SSE will have message events, and then they will close the connection. Okay. So as I mentioned just now, this SSE basically is a server-side event. Everything must have a state. Okay, but sometimes when the client and the server communicate, okay, not necessarily it is a stateful event. So now we have something what we call streamable HTTP transport. So basically, it's a more detailed interaction with something like this. Okay, you have a post request that initialize the connection, and then the client will respond. Post then a request, then the server will respond, and then towards the end, if there's no the client will get the notification. And then if there's and then the server will actually get back the result and get that result and send back to the client. Okay, so this could be the sequence. Basically, you have an initialization of the connection, then there will be a client request and server respond, and then you have the termination of the connection. So not to worry, you do not need to know all these things. All this communication is actually handled at the back by the SDK. Okay, so let's look at the most important part is the MCP server. So the MCP server actually have three capabilities. Like I mentioned just now, resource, tools, and prompt. Okay, so again, what is a resource? Resources basically is just to read a file, okay, file-like data that can be read by the client, okay, and then it could be API or it could be a file content that actually provide context to the application, okay, or to the large language model. Then you have a tools. Tools basically is a function that can be called by the large language model, okay, of course with the user approval. So they have many tools. For example, let's say I am using a GitHub MCP. Let's say I'm using a GitHub MCP. What are the tools that I can use? The tools can be maybe commit, okay, commit my gig, or maybe I want to gig pull, okay, or I want to gig push. Those are all the tools available inside, or function available inside the tools. Okay. Then they have a prompt. Prompt basically is a pre-written template that help the user to complete certain tasks. So the template could be a very long prompt, okay, where the user do not need to bother, all are already pre-written inside the MCP server. So for you as a user, a developer, when you write your own MCP server, you need to only consider three things, which is the tools, what kind of tools available, features or capability, what kind of resources that the MCP server can actually access. It could be a file, it could be a database, and what are the prompts that you want to, predefined prompt that you want to set inside your MCP server. Okay, so this is very important. Okay, so what's the difference between tools, resource, and prompt? Okay, what's the difference between tools, research, and prompt? So basically, tools are function. Okay, it could be a Python function. Okay, so it could be a function that this MCP client can call. Okay, but how does the function is called is decided by who decide when the function will be called. The function is decided to be called by the model. Okay, so let's say when you tell the LLM that say please commit this code to my GitHub, then the model, the large language model, will try to understand what are the tools available that I can use to do the Git commit. Okay, so this is very important. Okay, that means when you write your tools, you must make sure the model understands what this tool able to do. Okay, so what are the tools? Example, search for a flight, or send a message, or create a calendar event. These could be individual tools that you can create. Okay, then you have resources. So resources, basically the large language model, the MCP client, the MCP server can actually read, okay, a file, okay, that allow the model to have some sort of context. Okay, it could be a file, it could be a database, it could be API documentation. Okay, so who control this? This is controlled by the application. Okay, this is controlled by the application. That means once the resources is read, then the application will have a context. Okay, one example of resources like retrieve a document, access a knowledge base, or read a calendar. Some people will ask, isn't it tools and resource is about the same thing? It is about the same. So if you have a tools that read a file, that could be a resource. But you purposely define it as resources because you wanted to make sure that it only read a file to provide context to the application. And last one is a prompt. So prompt basically is a pre-built template that tells the model to do specific tools or resource. Okay, for example, plan a vacation. You can write a very long prompt. Okay, or vacation. What's the budget? How do I want to plan the application? You can write a very long prompt, and this can be stored as the prompt template. Or how do I summarize my meetings minutes? Or how do I want to draft my email? What kind of tone? How long? What's the length of my email? So this one, the user can actually define. Okay, the user can actually define when to use this prompt. Okay, so you will think that, oh, like this, it's very interesting now. When I would want to jump into and develop my own MCP server. Okay, actually, as I mentioned, MCP was introduced November 25th last year. So within less than a year, coming to a year next month, already there are many people develop many MCP server. Okay, most likely, if you think about a service, already there's probably someone have developed MCP server already. Okay, for example, if you look at the link here, you can see there's a collection of MCP server. Okay, that there are many people have developed. There are so you can see these are all MCP server out there. Okay, MCP server for AWS, MCP server for GitHub, GitLab, Google Drive. If you scroll down, you can see there are many servers that has been developed already. Okay, all you need to do is just call this server and connect to this server. Okay, so most likely, okay, there will probably someone that already developed the MCP server for you that you do not need to develop yourself. Okay, so you can see there are many people do a compilation of many MCP server. Okay, for example, this is an awesome MCP server, and people have collated many MCP server already. Okay, then this is like every big company like Microsoft, Google, they also have their own MCP server. For example, these are the MCP server built by Microsoft. They have the MCP for Azure, Fabric, you can see there are many MCP server. Most of the large company already have their own MCP server out there that you do not need to build, you just have to connect to it. Okay, you can see this one, another MCP server that you can connect to. Okay, you can see there are many MCP server out there. Oops. Okay, so basically with a host like Claude or VS Code or whatever, you can have the MCP client. They connect with the MCP protocol. You can connect to MCP A or B or C, and then you can actually connect to your local machine, local data source. This is through the standard I/O protocol. And then you can connect to a remote server using the web API, which is a remote server out there. Okay, next jump into MCP SDK. If I were to develop my own MCP, what are the SDK out there? There are many official SDK out there. For example, the official SDK out there is the FastMCP. Okay, FastMCP actually support multiple programming language. Okay, you have Python, TypeScript, PHP, and many more. You just click the official here. You can see there are many different type of SDK for different programming language. Python, Go, Java, Rust, Shift, Ruby. You can develop MCP server in any of the languages. Okay, and then there is today we are going to talk about Python SDK, which is based on this FastMCP. Besides the official SDK, LangChain, Llama Index, they also have their own MCP framework that allow you to develop this MCP server. For today, I'm just going to focus on Python using FastMCP. So what is FastMCP? FastMCP basically is a standard framework for you to build your MCP application. Okay, it allows you to actually connect to LLM tools, and then with MCP, FastMCP, it's very easy to do a production-ready, clean and Pythonic code. So basically, FastMCP is a fast Pythonic way for you to build your MCP server and your MCP client. How do you start? Just UV. If you're using UV, just UV add FastMCP. If you're using pip, just pip install FastMCP. Okay, so how does the code look like? You can see I can just import the FastMCP libraries. Then I just instantiate that I start a MCP server called demo. Then here I define a decorator for my tools. Then this is a function. So basically, it will be a tool that I can invoke, okay, which is called the add tools. Basically, this tool just take two number and then return the addition of these two number. Then I can just do MCP run. You can see the code is very short. So if I have more and more tools, I write another function for the tools and write another function for tools. Okay, so you can see this is the example. Okay, so you have import the libraries, then you start the server called demo MCP server. So for this MCP server, I have two tools. So I have one tool which is to add the string. The tool number one is actually to get a string and return the string. Tool number two, two tools is another function that I can actually invoke. So this is where you define the tools. Okay, remember just now I told you there are three things that you need to think about when you develop your MCP server. First is the tools. Second, if you have resources, basically it's just this is resources here for you to actually define where you want to get the resource. It could be just read a file or whatever. So this is you can just a function. You can read a file. You can read connect to a database. That would be the resource. And last one is a prompt. Okay, so you have a function here. Okay, where you're going to generate your prompt template. Okay, for example, here I will have a docstring here to say generate a prompt asking for the AI to summarize the tools. So you have what is supposed to return by this prompt. Okay. So remember just now I said the tools. Okay, is actually controlled by the model. So which tool to use? Okay, for which tool to use? Okay. For example, this tool here is called add numbers. This tool is called add numbers. Okay, how does the large language model know if I want to add number? It's supposed to call these tools. So you as a developer, what you need to do, you need to provide a very understandable or docstring where the large language model can understand what you intend to do. Okay, for example, this is a docstring will allow the AI to understand the purpose of the tools. Okay, so you can see here I will say the purpose of this tool is to add two integers together and suppose to return the sum. And what is the argument? There's a two argument, the A and a B, the first integer and second integer, and what's supposed to be returned by these tools, which is the sum of these two integers. So the large language model, when you give instruction to say, can you go and add 4 plus 5? So you understand that, okay, now I have 4 plus 5, what are tools that I need to call? So he will try to call add underscore numbers tools. Why? Because based on this argument, then this is the right tool to be called. Okay? So you as a developer, you make sure your docstring here should be clear for the large language model to know what tools to be called. Okay? Okay. So as a developer, one of the things that you can do is to inspect. Okay? When you write your MCP server, how do you inspect whether your MCP server is working correctly? How? So in the MCP SDK, it comes together with a tool called MCP inspector tools. Okay? That means you do not need to write the client. You need to just run the server and you can inspect the MCP server whether it's working in a correct manner or not. Okay? So the MCP inspector basically is an interactive developer tool for you to test and debug your MCP server. Okay, remember in the MCP architecture, you have an MCP host, you have the MCP client, you have the MCP server. Okay, let's say you already developed an MCP server. How do you test whether your MCP server working correctly or not? That means you need to have a host, you need to have a client. Okay, but you have not written the client yet. So how do you test the server? You can use the MCP inspector to test your server. This is allow you to test and to debug your MCP server. So basically, this MCP server is built on 3 components where the inspector can allow you to examine. Remember the 3 components for MCP server: the resource, the prompt, and the tools. Okay, so in the MCP server, you can test your prompt, you can test your resources, and you can test your tools. Okay, with the inspector, you can run and check all the history and check all the method, the token, the argument, the command, and transport. Okay, so it allows you to make sure your MCP server is working as what you intend it to do. So in the MCP server, basically is a visual debugger, allow you to connect to MCP server in a very user-friendly interface. It has a very powerful CLI support. Okay, you can do prompt and tool testing. You can test your resource, you can test your prompt, and you can test your tools, and you get a real-time feedback. And every single time you test, you have a very clear output and log. You can visualize your result, the error, and all the logs. And then you can connect to any MCP server, whether remote or local, okay, without setting extra setup. Okay, so to install the MCP server, you can install MCP install and then model context protocol / inspector. To run, you just use npx model context protocol inspector. Okay, so the MCP inspector looks something like this. Okay, for example, here I have a local host server that's running on port 42,000, and then this connected using HTTP, streamable HTTP. So once I connect to it, I can test the resource, I can test the prompt, I can test the tools. Okay, so what I can do, I can test inside here. Okay, let me show you how does it look like. Okay, so where is my MCP inspector? Okay, so this is my MCP inspector. It looks something like this. Okay, so before that, let me start my server. So Okay. Okay, so I started my server. You can see my server here is running on this localhost port 42000 MCP. Now I can connect to my server. So I connect to my server, which is this 42000. So you can see now I'm connected to my server just now. So here I have tools. I can see the tools. I can list the tools. So inside here, inside my remote server, I have 3 tools: say hello, say goodbye, and say welcome. So I can test every individual tools here. For example, here I can say, let's say my name is Guan Hong. I enter, run the tools. Okay, you return back, okay, hello Guan Hong for me. So as you can see, this tool is working. Okay, so you can see now. Inside this MCP inspector, it allowed me to test my MCP server without me writing the MCP client, and then I can actually inspect all my tools available, whether it's working correctly or not. Okay, you can see I can have a prompt. Okay, for my code here, I don't have any prompt. I don't have any resources. Okay, but I have 3 tools that I have developed. So you can use the MCP inspector to actually run and see the result. Okay, so what are the MCP use cases? Okay, so for personal usage, let's say you have, for you as a end user, how do you use the MCP, use MCP for in your personal life? So you can use it to maybe do time and schedule management. So you can connect your MCP to your calendar. For example, you can connect to your Google Calendar. Okay, you can actually just use your large language model to set calendar, to schedule meeting, or to set reminder. Just type in the prompt. Okay, can you remind me or check my calendar? Is there any upcoming meeting that I need to attend? Okay, you can just type in your large language model. Okay, then if you are doing coding, you can use MCP to actually fetch snippet, do improvement, or commit your code. Okay, like I explained just now, you could have a GitHub MCP. Okay, MCP, you can connect to your GitHub MCP server. Okay, you can actually just write in a prompt and say, oh, can you push this code for me or commit this code for me? Okay, you can just put in a very natural language, and then you can the large language model will connect to the MCP server, and you will actually invoke relevant tools to actually commit your action. Okay, then you can use MCP for information retrieval or research. Okay, some people have developed an MCP server for WhatsApp or Slack. Okay, so you can actually connect your large language model to your Slack or to your WhatsApp. Then you can actually do some query to your WhatsApp or to your Slack. Okay, I'm sure that probably you have many Discord messages or WhatsApp messages or Slack messages that you can actually use to connect to the MCP server. Then you can do search, you can do summarization, then you can do information gathering. Okay, so you can also use all this MCP server for you to do some automation. Okay, for example, you can actually connect to the Figma MCP server. Then you can actually convert the design to a code. Then if you are on to share market or whatever, then you can connect to your fintech MCP server. Then you can retrieve the stock price or execute trade based on this market data. Okay, for business usage, similarly, you can actually connect to all this calendar MCP server. Then you can use it to actually schedule meeting, check your booking room or whatever. Then you also can, if you are using Slack or the Google Doc or Google Drive or Confluence or Jira, then you can actually connect to all this server. Then you can do summarization, discussion, or auto-generate reports or minutes. Okay, so for example, you can connect to the GitHub MCP server. then you can actually create issues in the GitHub. Then whenever you resolve the issues, okay, you can actually make sure you use the MCP server to mark the issue being resolved. Okay, so like developer productivity tools, like I mentioned, GitHub, internal report, Jira, all those things, and then you can fetch the code, analyze changes, suggest improvement, and maybe automate your commits. Okay, a lot of companies now are developing internal MCP server. That means you have all these tools like Confluence or Jira or whatever. Then you can actually use the MCP server to connect to all these services, and then you have an MCP server running internally. Then the user just have to use the large language model, give a prompt, then you can get all this information together, and then you can actually analyze it. Okay. Then you can access to real-time data. You have an MCP server for weather, for stock prices, and then you can actually connect all this MCP to your AI model and to external API. Okay. So how do you deploy MCP server? Okay, deployment is very important. After you write your MCP server, you need to make sure people can connect to it. Your client can connect to it. Okay, so you can actually have two ways. Like I mentioned just now, you can deploy as a local server, or you can deploy as a remote. Okay, so for example, if you deploy in the local server, you can deploy using this standard I/O transport, or in HTTP transport. Okay, MCP server also can be deployed onto the cloud. Okay, that means once you deploy a cloud, you just have an endpoint. You can actually connect to the MCP server. So you can have deploy, for example, into Google Cloud Run or AWS Lambda, something which is serverless that you can actually run. Of course, if you deploy into remote server, the server must have a single HTTP endpoint, okay, that the MCP client can connect to. Okay, so it could be something like just now I show you, local host, what port, the MCP. So I'm not going to go into talking about deploy into the cloud. There's a very good article on how to deploy to Google Cloud Run or AWS Lambda. Okay, so you can see the internet is where you deploy into the remote service. So if you want to deploy into the Cloud Run, okay, there's a very good tutorial how to deploy MCP server on the Cloud Run. Okay, don't worry. All this slide I will actually share together with the recording later. There's also a very good GitHub instruction how to deploy your MCP server into AWS Lambda and run it as a Lambda function. Okay, and with this FastMCP, MCP server now can be easily integrated to AI assistant like your ChatGPT, your Copilot, or Gemini, whatever. And then the transport mode can be HTTP or standard I/O. Okay. So for example, like I showed you just now, I will have my own MCP server, running on my local machine, and then my Claude Desktop just connect to my local MCP server. Okay, and then if I'm running or something on the cloud, I using that tutorial just now, I deploy into the cloud. Okay, and then this is the endpoint, and in this endpoint I can add to my Gemini CLI, and now I can connect this MCP server through the endpoint provided by which I already deployed in the GCP. Okay, so to demo, you can actually go through this GitHub. So let me share the link in the okay, so the link here. Okay, so the GitHub there is available, the code is available. I just want to show you this. Okay, so this is the code just now I have shown you just now where I checked with my MCP inspector. So I have an MCP server called space node, okay, and then I I have a tools where I can actually add nodes. So the add nodes is a tool where I will append new nodes to the sticky node. Then I have another tool called read nodes. This will just read the nodes. Then I have a resource that define that will read the resources. So I will resource that read. Then I have a prompt. The prompt basically is to generate a summary from my current nodes. So all these things, this whole server here, I can run inside my Claude Desktop. So let me show you my Claude Desktop. Okay, so I can say add node that 3i atlas, the comet is currently behind the sun. So now what's happening is, okay, the Claude Desktop will say that he's going to use my, okay, you can see he actually using the function, which the tools that I've written inside my MCP server, okay, which is the tools here. This where's my space node? Space node. Inside this space node here, there's two tools: read nodes and add nodes. Okay. Then I say show me all the nodes. Okay. Now he will actually now try to use the read node. So allow always. He will read the nodes. He will invoke these tools called read nodes. Then he will read the file, all the nodes available. So I have actually added two nodes inside. The 3i atlas behind the sun, and then the 3i atlas is the newest interstellar comet. Okay, and then I will say maybe do a summary of all the nodes. So now I have a prompt that's supposed to do a summary for me. So you can see now, you can say now I'm tracking position behind the sun, and then this is the interstellar. Because inside my nodes, I have a context, the resources to say that this 3i atlas is actually an interstellar comet. So you can see, basically now I'm connecting my Claude Desktop to my local machine that I can run, and the MCP server that's invoked inside my this Claude Desktop. Okay, another thing I want to show you is this. Oops. Let me show you this. Okay, I have another server here. Okay, I have another server. So I have this server here actually going to run. One is a local server, one is a remote server. So the local server basically have this 1, 2, 3 tools. Add numbers, subtract number, multiply numbers. And then the remote server is going to run and have 1, 2, 3 tools. Okay? And then I will say I can run it as a HTTP, or I can run it as a standard I/O. If I run as a local machine, then it will be standard I/O. If I run using HTTP, then it will be running as a HTTP transport. So let's say now I want this. I want the remote server to have 3 tools. Okay. Okay. So let's say I save this. I run this. Let's say I run this. Sorry, CD. So let's say I want to run this. UV run server.py HTTP. I'm going to start this server now. So this server is running now. This server is running. Let me close the other server. Then I have another machine here. Okay, now I want to check ADK web. Okay, so I've started the ADK web. If you do not know what is ADK web, please go and watch my previous video. So 127, okay. So in SDK web here now, I'm connected to my server, which is the server, remote server that I started just now. So I say, hello. What tools do you have? So you can see now, sorry, because I run multiple, I run all the tools. That means now it can actually running. You can actually connect to my, so you can see my code here. So you can see my code here. Where is it? This. Okay. So where's my agent? Let me open my agent file. Okay, so inside my agent file here, see I am running these two tools. Okay, the MCP local tools and the MCP remote tools. Okay, so these are the tools available. These two tools are working now. Okay, and then I can see that inside my server here, I have add number, subtract number, multiply, say hello, and say goodbye. Okay, so when I check my SDK web, you can see add number, subtract, multiply, say hello, say goodbye, and say welcome. These are the tools available now inside my this. Then if I say hello, sorry, my name is say hello. I think I got this. Wait, I got this running just now. I should continue this. Let me start again. Yeah, because I started, I should run again. UV run server.py. Before that, let me show you an agent here. I only want to run my local tools. So this one. Local, okay. Okay, now I'm just running my local tools here. So you can see the server started is stdio, that means running on local tools. Then if I run my SDK web, let me go back to my SDK web again. Let me start. Okay, so I say what tools do you have? Okay, see, because I'm running local, I have three tools. Okay, add numbers, subtract, and multiply numbers. Okay, so if I go back to my, here I can see it's only local tools. So local tools, if I look at my server, Local tools will have this 1, 2, 3 only. It doesn't have this remote. Okay, so let's say now I do not do anything. I just restart my server. Okay, so this one I disconnect again. Then I say start HTTP. Okay, now it's running on a remote server. So if I go back to my ADK web, then I ask again, what tools do you have? Oh, sorry, did I check? I need to start back my server again. Sorry. So you can see agent here. I want to have now all the tools. That means now I want to have my local tools and remote tools. Okay. So I've saved this. Let me restart my ADK web again. So let me restart. Then I ask, what tools do you have? Okay. So even though I just started the HTTP server, now I can have all the tools. Okay. Then let's say now I just want to add one more tools. Okay. I didn't do anything to my ADK web. I just go back to my server here. Go back to my server. I just uncomment this. That means I want to add one more remote tools. And save this and run again. Let me run again. Start my server again. Then if I ask I didn't do to my ADK web, I didn't start the ADK web again. Then I ask again, what tool do you have? Okay, just now I didn't restart my ADK web. Just now I only have say hello and say goodbye. Now I have say welcome. What does that mean? That means if there's any update at the server side, okay, there's no need to change anything at the client side. The update will be reflected at the client side as long as you update the server side. So you can see now suddenly I just changed, I activate the new tools. Now I can see at my client side already. So we will say welcome to Guan Hong. Okay, here he will connect. He will know that I will call the tools call say welcome. Then I can check here. These are the requests coming in. Okay, sorry. You can see my agent here can have many tools that it can call. Add numbers, subtract numbers, multiply, say hello, say goodbye, or say welcome. Then this is the connection, and this is the message being sent. You can see the request, and the response, the events. Okay, if I see here, then this is the connection being developed. Then if I say add 4 and 5, you call the tools call add numbers, and then you return back the result. So you can see here, he's calling this add numbers tools. Okay. Okay. So I think I have demo quite. You can go back and play around if you're with the GitHub. So basically, to conclude, with MCP, basically MCP will enhance capability, extend the large language model capability beyond the base model. As a user, as a developer, it allows you to streamline your development. It simplifies your workflow integration for AI application. It's very flexible deployment. You can deploy your MCP server, local or cloud-based. Okay, and then, but of course, there are too many MCP server out there. You need to be cautious around the security implication and also the token consumption. The more MCP that you use, the more communication between the large language model, between the server and the large language model. Sometimes it will actually burn out your token. So that's why if you're using like Cursor or you're using like VS Code, if you add your too many MCP server, you feel like the token being used is very, very fast, because it will use up more and more token when you communicate with the MCP server. Like I said, MCP server has been around for less than a year. There's definitely a tremendous growth and tremendous adoption. And there are many, many use cases across commercial and personal application. So thank you. Please connect to me in LinkedIn.